All right, so one more video. I want to keep this one shorter than the other one because I want to say, how do you figure out this without bothering with everything else? So how do you just solve the inequality? Computing all those sample points was a little bit annoying. You had to type a lot of stuff into the calculator. You had to do a really sort of a tedious compute the number a few times, and it was just if there's a way to sort of skip a little bit of that and use sort of some knowledge that we already have, then maybe that would be better for us. So that's the goal here. I want to describe if I don't have to compute, if I don't have to construct an entire graph, how do I just solve the inequality? So what if I don't like sample points? What if sample points are annoying? Well, let me just keep a little bit of what I had before. Previously, we figured out that this was actually going to be. I'm not even going to tell you what the numbers are anymore or what the sample points were. But the end result was this. So let's see if our previous work gave us this. Let's see if we can understand it another way. All right, so let's say, well, this was really important though. We found that there was a hole at -2. We found zeros at -3 and at +2. And we found a vertical asymptote at x equals 4. So that's still important. But let's see, what's contributing to whether it's positive or negative? So overall, there wasn't a negative that was factored out front, so what I want to do is I want to split up the number line, and what we're doing is we're multiplying and dividing things, and we're just going to count how many negatives we've got and whether they cancel or whether we've got one negative left over. So what we have is what are our factors? We've got an x minus 2, we've got an x plus 3, and we have an x minus 4. So this is an alternative method where it doesn't help us with the graph very much. To get a graph, what we really do is if we're graphing the function, we really do want sample points in between to get us just a very minimal picture of what's actually the shape of the function. A couple of reference points to pass through is kind of nice to have to get a nice graph. But here, so x minus 2, what does x minus 2 do? X minus 2, x has to be bigger than 2, and then x minus 2 is positive. If x is bigger than 2, it's positive, but then it's negative here. Because x equals 2 is when this one is equal to 0. If you take like 0 or 1, x plus 2 suddenly starts being negative. Let's try x plus 3. So x plus 3, if x has to be bigger than -3, and then everything is fine. So you plug in -2, and this is positive. You plug in -4, suddenly it's negative. And finally, x minus 4. So this one is negative for a long time, but then once x is like 5, or if it's 4.1, it's positive. And then kind of you're multiplying and or dividing these things. So you get minus, plus, the function is negative and then it's positive again. And that's our old work said that this is what happened, and now we're getting exactly the same result. So that's an alternative method, sort of just by analyzing the factors. That's an alternative method for figuring out the inequality. When is the function positive? When is the function negative? And then the analysis of what happens exactly at the endpoints is still, you have to look and do that the same way as before. If you're not actually graphing it, you just want to solve the inequality, this is, I think, considerably faster. It's no more or less correct. For me anyways, because there are less computations, I'm less likely to make mistakes. So I kind of like it. I would like to do one more kind of in a similar style. Just because it's an alternative method, but it's a really nice one that I pretty much like. And the only thing is there are some, maybe in this class, or maybe you're going to see more of this variations on this as well. It comes up, your next 2 or 3 math classes will probably run into this kind of problem or something related. So let's sort of dig a little bit deeper here. So wait for it to dry just a little bit more before I can actually write properly. Okay, so we got Alright, so this one might be a little bit tricky, but let's actually, you gotta be careful about your factoring. This is a difference of squares. The numerator is actually x minus 2 times x plus 2. And the denominator looks like that. So what do we have here? So x equals 4. There's like a multiplicity 2 on that as well. So the denominator is 0 and x is 4. The numerator is not 0, so it's not a whole. There's nothing canceling the x minus 4, because the x squared minus 4 is actually it's x minus 2 times x plus 2. So the zeros of the numerator are somewhere else entirely. So vertical asymptote, because the numerator does not have enough zeros to cancel the zeros of the denominator. All right, so where are the zeros then? X equals 2, x equals negative 2. So we've got 4, 2, minus 2, and because this is not a graph, this is just a number line. It's being able to have enough space to write is sometimes more important. So what do we have? We need everything. So we have got x minus 2, we've got x plus 2, and this one is a little bit slightly different from last time. This x minus 4, we don't just have x minus 4, we have x minus 4 squared. So we can go ahead and we can keep both copies, but we have to be methodical about this. Is this marker a little better? Yes, okay. So x minus 2. Oh, if it were 2 minus x, it would be the opposite. But anyway, x minus 2 is positive when x is bigger than positive 2, and it's negative. You can double check real quick. You can plug in 0. It's easier for one factor than having 4 different factors over and over and over again. You just do it separately. So this one, the plus minus is, this factor is negative when x is here, less than negative 2. This factor is negative when x is less than 2 but greater than negative 2. And it's positive between 2 and 4 and between 4 and infinity. X plus 2, well, negative 2 is where it's exactly 0 for that factor. This factor is negative when x is like negative 3, for example. But then it's a positive. Otherwise, this one right here. Okay, so this one, x equals positive 4 is where it's equal to 0, but actually it's squared, so you plug in a 0, you get negative 4 squared, but that's still positive. So this one's actually positive no matter what. But what do we have? We have vertical asymptote, we have 0. We wanted to understand the graph better. Well, maybe it would be nice to have some sample points if we actually want the graph. But this x minus 4, nothing. We do have a vertical asymptote, which is interesting, but the function is it's positive on both sides because the factor that could have changed from positive to negative, well, it didn't change. That factor was squared, so it stayed positive. I really like this method. It really gives you a big picture. Computing the sample points can be it just takes so long, and you make one tiny mistake and your answer is the opposite of what it should have been, and that's really, really frustrating. I feel like this one, you really, really get the big picture. By doing this. So f of x, so where is f of x strictly greater than 0 from minus infinity to minus 2, union from not for this part in the middle, but then it is from 2 to 4, but not exactly 4. You don't include 4 because that's an asymptote. And then you go from 4 to infinity. And similarly, f of x greater than or equal to 0. I don't want to be too repetitive, but I'll just do the graders, the less than, same ideas as things we've done previously. But when is f of x greater than or equal to 0? Well, same endpoints, but then is it a 0 or is it an asymptote or is it a hole? Well, there's no holes, but we got a 0. And if we're greater than or equal to, well, the or equal to means this time we include it. Union 2 is a 0, so we actually include it. And we go all the way up to 4. 4 is a vertical asymptote, so we don't include 4. And then we don't include 4. And then we go all the way out to infinity. So I don't want to, I think that's all I want to do. Actually, f of x less than 0, we can see it right away. So f of x, sure, this will only take a minute. Because there's only one of them. That's pretty painless. Less than or equal to. The endpoints, the function is actually equal to 0 at the 2 endpoints. All right, so this is pretty cool. So one way you could organize the graphing problems, you could do it this way. I find that this is there's something very minimal and kind of satisfying, and you really see the big picture, how it's made out of its individual parts this way. I like it a lot. If you're actually making a graph, then after you do all this, sure, maybe you still need sample points to put a graph together. And that's something you can do, but getting the big picture first, wrestling with sample points is just once you can do it, once you see that you can do this to get the big picture, it's really nice, and then you can do sample points after the fact. And whatever you find for your sample points should probably agree with this. And if it doesn't agree, then either you made a mistake here or you made a mistake evaluating your function on the sample points. So you have a lot of different tools. There's when you're just sort of practicing, you can even use online tools, but make sure your final answer, you're gonna have to do all your work for yourself on paper. Use the calculator for arithmetic and all that, but just make sure your final answer, you use all of these methods, everything that I've kind of shown you here, or something, equivalent, and show your work. If you do want to check your answer by doing something, there are things that there's software and various computer programs where you can get a nice graph immediately, and that's something you check your answer against. The graphing calculator can do it if you zoom the windows certain ways to see everything on to get it all to fit on the screen. But yeah, that's how you do it by hand. That's how you see the big picture. If you end up getting a contradiction, if you evaluate the function and you get -7, well, either you're wrong here, or you made a mistake plugging in the numbers and you forgot, you didn't cancel all your minus signs. There's one left over that you missed or something. So that's the trick. So hope that's helpful. The book doesn't include it this way, but if you use this technique or something very similar to that, and you're very careful and you set it up very clearly, then that's a really useful thing that I encourage. All right, so that's it, yeah.